Hello, welcome back to modulus functions and solving modulus problems. So last video I'm going to do on this is just exercise 2e and a few questions from that on the sketching side of things. So there's not a lot to this, just looking at how you sketch these modulus functions. You're going to follow the same rules we did before. If you get something that looks a bit like this, you'll notice that they've given you specific points in their coordinates. So it's important that when you resketch these things that you write in the specific coordinates that have moved, because that's how you're going to earn the marks from these questions, is how the graph is going to end up looking and what happens to any specific points. So we'll start with looking at mod of p of x, and how to sketch mod of p of x. Simple rule is anything that sits below the x-axis you're going to flip up and reflect in the x-axis. So if I wanted to, I could say start with anything that is already above the x-axis and sketch that in. So this bit over on the left is already above the x-axis, and that's the point A. From the point C up to D, down to E, is also above the x-axis. So all of these bits will still be valid, but the point B sits below the x-axis. Now that's going to be reflected in the x-axis, and it's going to look something like this. Now remember, I need to mark in the point B, and it was -4, -5. So what's changed is not the x coordinate, but in fact the y coordinate, and it's going to become -4, 5. So that is going to be mod of p of x. P of mod x, the rule for that is get rid of anything that's on the left hand side of the y-axis and then reflect anything that's on the right in the y-axis. So all this stuff on the left, forget about it. We're going to start by sketching what's already on the right. So from D down to E and then off again. So this is all valid in the graph of P of mod x. Then we're just going to reflect that in the y-axis. So it looks a bit like that. Ooh. Now the coordinate over here is going to be a direct reflection of E in the y-axis. So the x coordinate is going to change to -2. The y coordinate will stay the same at 1. So this is the graph of P of mod x. Okay, let's have a look at question 9. Now these are two graphs that you should know how to sketch. The graph of e to the power of x and e to the power of -x. So the first question is, can you sketch the two of them on the same axes? E to the power of x, you must know, looks something like this, and they've called that f of x. E to the power of -x is a reflection in the y-axis of that, so it looks like this, and they've called that g of x. So that's part A. Two graphs you should know how to sketch already. Part B, it says explain why it is not necessary to sketch mod of f of x and mod of g of x. Well, if you look at the graphs already, by their nature they sit above the x-axis, and there is an asymptote here as well, so none of it goes below the x-axis. And remember what mod of the whole function does: anything below the x-axis will be reflected above the x-axis, or in the x-axis. Since there is nothing below already, there'll be nothing reflected, and the graphs will not look any different. So the answer to this really is they would look the same as the originals. So they would remain unchanged. You can go into as much detail as you like on this, but that's the reason. Okay. Part C says sketch the graphs of f of mod x and g of mod x. So remember what they do. Anything on the left hand side you can get rid of, the left of the y-axis. Anything on the right hand side will be reflected in the y-axis. So let's look at f of x first. F of x on the right hand side looks like that, and then reflected would look something like that. G of x, I'm going to choose a different colour, on the right hand side looks like that, and reflected would look sort of like that. Sorry about that. So that's G of mod of x, and then this one is f of mod of x. Okay. Right, last question we'll look at is question 10. Now this is something that's called a piecewise function because it has two different rules for two different sets of x values. So it's saying between -5 and -1 the graph is -2x minus 6. So that's a straight line. And then between -1 and 2 we've got x plus 1 all squared, which is a quadratic, so it's going to be a curve. So let's look at what happens between -5 and -1. We've got the graph of -2x minus 6. So we know it's got a gradient of -2 and it's going to cross at -6, but we could simply think about what happens at each of these values. If we sub in -5, we're going to get 10 minus 6, which is 4. It's going to be somewhere up here. If we sub in -1, we're going to get 2 minus 6, which is -4. And if you sub in 0, or equate it to 0, so find out where it crosses the x-axis, we're going to get -3. So we've got there a straight line that looks as straight as that. Okay. So that's what happens at those points. Between -1 and the point 2, we've got a quadratic curve. If you sub in -1, you're going to get 0. If you equate to 0, you're going to get 1. So it's going to cross the y-axis at 1, and it's going to curve up like that. If you put in 2, you're going to get 9. If you sub in x as 2, you'll get 9. So that's what the graph will look like. A follow-up question on this, it says state the range. So the range is all the possible y values that it could take. If you just look at the highest possible value, that's going to be 9. The lowest possible value is going to be -4. You need to be slightly careful when stating the range now, because the function f of x now could take any value between those two, but does it include those two? So f of x can be anywhere between 9 and -4. It does include 9 because we're including 2 in the domain. So that's going to be a less than or equal to. Does it include -4? Well, the bit that goes down to -4 is the linear graph, and that doesn't include -1 in the domain. It goes as far as -1, but doesn't include it. So that's not going to be a strict inequality, it's just going to be a less than. So there's the graph, there's the range. The next two parts quite straightforward. So B asks to find y of mod of f of x. So the rules for that are anything that sits below the x-axis gets reflected above the x-axis. So anything that's already above we can sketch in. So let's start with this curve. That already sits above, so I'm going to leave it there. And then part of the linear already sits above the x-axis. I'm going to draw that in. The bit that's below is going to get bounced up, and that's going to go up to 4. So that is mod of f of x. Part C, f of mod x. So again, anything on the left hand side, get rid of it. So that's all of this line and a bit of the curve. Anything on the right I'm going to sketch in already, which is that, and that's going to get reflected in the y-axis, so it looks like that. So there you go. That's question 10 from 2E.